Hello everyone. Today I would like to go over just a few things. I would like to go over cash flow diagrams and the basics of cash flow diagrams. These are required for your homework and you must show them. It explains how you are doing a problem and how you understand the problem to be. Then we'll look at this with the single payment method. And if you look in the front cover of your book, it shows all the different payment methods, and the very first one on the top left is the single payment method with its cash flow diagram and its equation and this functional notation. I will also want to talk about how we deal with this functional notation. I think that's very important and makes life a little bit easier for us. But first let's look at our cash flow diagram. If we look at our cash flow diagram, we have our timeline, and typically we have some money that is going out, and then we have some money that is coming back to us. Typically we might be investing or buying something over some period of time, and then we'll be getting this money back out. If we look at this, we usually label it and give it some time frame. So we'll say we'll do it at year zeros when this is first happening. Then we have 0, 1, 2, 3, 4, and really I want this to be 5. I'm sorry, we'll try and kind of get it a little more even here. And chop that off. Okay. And then we should label our cash flow diagram. We're going to have some value of P that we want to invest. This is at time 0, 1, 2, 3, 4, and 5. We'll call those 5 years. And we want to get some money out, F. Okay? So this is our basic cash flow diagram. Typically we know our N is our number of periods, and then we have some interest that we're looking at also. Okay, and that gives us all our givens. So in our typical problem, when we write our problem, we can state this as our givens, right? This is what we know. And P is what we're trying to find. So that's our givens and our finds. So that makes life a lot easier than in chapter 1. And then we'll have to write out our solution here and how we're going to solve this problem. Okay. So let's actually make this a problem itself, okay? Let's look at this, and let's just say, let's put a little more information in here. Let's just say F equals, in 5 years, we want to save enough money to buy some large purchase in 5 years of $40,000, okay? We want $40,000 purchase, okay? And that's in 5 years. Sorry for the pen problem. So that's in 5 years. So we need to find out how much do we need to put in today to have this $40,000 in 5 years. Okay, and this is pretty simple to do by using the formula. We know the formula equals, we have that if we look in the front of the book. We see that the formula is P equals our F, which we know, 1 plus I to the n power, right? And we see this part right here, this 1 plus I to the n power. Well, that is something we could calculate out each time. But the problem with doing that is sometimes we get errors when we do our calculations all the time. So it's better to really rewrite this whole thing in a functional notation. So let's do that. Let's write this in functional notation. We still have our F. That's the same as before. But now we have, instead of 1 plus I to the n power, we are going to write it in functional notation. And that functional notation states it this way. Find P given F at some interest rate, I, for n periods. Okay? So in this case, what we have is this term is equivalent. These two are equivalent to each other. They're the same thing and interchangeable. Now for single payment method, this formula is very easy to work with and it's easy to solve, but it gets a little more complicated when we get into our uniform series and arithmetic gradient series, and it gives us a lot more chance of error. So if we use this functional notation constantly and all the time, it'll make life a lot easier, less chance for error. All we do is look up in the back of the book in Appendix C. We can find in our tables what that interest rate is. Okay, so for this problem, let's give an interest rate of, say, 12%. Okay? What amount of P do we need to put in to get this $40,000? And I'm going to solve it using the functional notation. So we are still looking for P. P equals, and we know it's $40,000 times, find P given F at 12% for 5 years. And if we look up that value in the back of the book for this functional notation, we will find, let me get my paper out here, let's see if we can find that, 12, and we're doing it for 5 years, and P given F is 0.674, which means that P is equal to, let's calculate that out, 40,000 times 0.5674. It will equal, P will equal $22,696. Not bad. At 12% interest, it's a nice interest rate, but that's what we would have to put in. We know the time value of money means that it should be less, right? If I give someone $22,000, hopefully in 5 years I get more money back. And that's what this is showing. Let's do this same problem again, but typically banks don't pay out just once a year on their interest. They compound it monthly. So let's look at this a little bit differently. And this time, let's say, we'll use the same cash flow diagram. And let's look at it here. We'll have the same cash flow diagram. Because of space, I'm going to just kind of make it a little bit smaller. 0, 1, 2, 3, 4, 5 years, it says. And we have P we don't know again. And we don't know our F. We do know, I'm sorry, is 40,000 again. We still want this 40,000. And N is equal to 5 years, but the problem is it's compounded monthly, right? Our interest rate is still, we need to work in the same units. So we have I is equal to 12% per year, right? We need to multiply that times 1 year divided by 12 months. And if we do that, we know our years will cancel out, and we will end up with just 1% per month. Well, this is in years. We need to change this to months also. And we know if we multiply that times 12 months per year, that will equal 60 months. Okay. So we can quickly solve this problem now. Again, using the functional notation will be easiest. Again, P equals 40,000 times find P given F at some interest rate, which in this case is 1% per month for 60 months. And if we look that up in our table, our 1% chart, and we look up 60 here down the side, n is equal to 60. Here it is. And find P given F. I note that that value is, for this, 0.5504. Therefore, P equals, let's calculate that out, 40 times 0.5504 is equal to $22,016, which is less, which makes sense because we're compounding our interest more frequently every month as opposed to every year, so we have to put in just a little bit less money than the beginning. So that's really it for showing cash flow diagrams and the single payment method. I just want to take one more note or one more comment about this. Again, please be careful on what this stated problem says as far as interest rates. A lot of times the problems state, and we always work with compounded interest, it will, and usually is stated in yearly, it will say, and the interest rate is 12%, versus the monthly rate is 12%. If it says the monthly rate is 12%, then that's what it is every month, and we don't need to divide by 12 or anything like that. But if it says that the interest rate is 12% compounded monthly, that is when we need to divide it. So that's the two different ways. And typically that's how it's stated, is that the interest rate is, let's just say 10%. That means that it's yearly, compounded, it will tell you quarterly or monthly or some period, so it could be quarterly, right? Then you'll need to divide it by 4 to find the value. Okay? So hopefully that kind of straightens things out for you. I mean, the other way that it would state it is that the quarterly interest rate is 10%, and then you would not divide it. If you have any questions on this, please email me, and I'd be glad to help you out with this. Thanks, and have a great day.